Going all the way back to year 7, you probably realise that parallel lines all have the same gradient. That means they all have the same coefficient of x. So the gradient of this line here, y equals 4x plus 1, has a gradient of 4. So here's a question for you. Find the equation of the line that is parallel to y equals 4x plus 1, but goes through the point A, 5, 17. So we've identified here already that we're looking at a gradient of 4. We don't know what the c value will be at this point, but we have been given the coordinates 5, 17. So if we substitute that into y minus y1 equals m lots of x minus x1, and substitute the values in we've got, we should be able to find the equation of the new line. So we should have y 17 equals 4 lots of x minus 5. Multiplying things out, we get 4x minus 20, and they're rearranging y equals 4x add 3. So we've now found the line that is parallel to y equals 4x plus 1, but actually goes through the point 5, 15. And if you want to check that, if you substitute 17 in for y, you get 17 equals 20 take 3. My mistake there was adding 17 onto minus 20 should give you minus 3. So I was using these values as a check, and by doing my check I spotted that I'd been very careless with my addition subtraction. So the answer is y equals 4x take 3. And here's my second example. Find a line that's parallel to y equals a third x minus 4, but goes to the point a 9, 8. So we can tell our gradient is a third. Our coordinate point is 9, 8. So substituting into y minus y1 equals m lots of x minus x1. Off we go. We've got y minus 8 equals 1/3 of 9, of x minus 9. What I'd be very tempted to do here is multiply everything by 3 to begin with. So I've got 3y minus 24 equals x minus 9. I can rearrange that to give me 3y minus x minus 15 equals 0. That would do as my line. If I wanted to put it into y equals mx plus c to find the intercept, I could. I'll go up here now. That would be 3y equals x add 15, divide everything through by 3, gives me a third x plus 5. To check, I'd substitute my coordinates 9 and 8 into either this one, which would give me 8 equals a third of 9 is 3, add 5 is 8, so that's correct. Or I could try it here. 24 take 9 is 15, take another 15 is nothing. So I've been able to check by coordinates in. Okay, your turn. Find the line that's parallel to y equals a half x add 10 and goes through the point a negative 6, 2. Press pause and have a go. Let's see if you got this one right. So we can identify that the gradient m is a half, and we're looking to go through the point negative 6, 2. So we're going to use y minus y1 equals m lots of x minus x1. Let's begin substituting in. Y minus 2, got it from here, equals a half times x minus minus 6. So that's y minus 2 equals a half times x plus 6. It's going to be easier for me to multiply both sides by a half now to give me 2y minus 4 equals x plus 6, and a rearrangement will give me 2y minus x minus 10 equals nothing. That's the correct answer. If you wish, you can put it into the form y equals mx plus c. So rearranging that again gives me 2y equals x add 10, divide everything through by 2, gives me a half x add 5. And just to see that I'm correct, if I substitute negative 6 into here, I get half times negative 6 is negative 3, add 5 is 2. Just going to check down the bottom. 2y is 4, take negative 6 is positive 10, take 10 is 0. So I've been able to check using my coordinates.